Now from here we have a standard ball end mill, as you can see on the screen. That's fine. What we're going to take a look at is the pattern area. And you can see that we have it set up for patterning for slice. We're going to do zigzag, sequential. That's all pretty standard stuff. Let's go to axis control. And axis control tells us which way we're going to go, and then the cutting tilt direction options that we have here. And what we want to do is we want to go tilted through a point, and we want to go through the z-axis, as you can see here. And you can see on the little diagram it tells us that it's going to tilt through that point. Over here is where we're going to tell it where that point is, and we're going to use the center of that little dot right there. Now everything is going to try to go through that point as it machines down into the part. Now for finishing, you can do you can pick your deviation and how everything's going to be blended. If it's going to be blended by tool radius, if you wanted to extend out the tool paths to make sure everything blends correctly. All these options are here to be set. The next one we're going to look at is we're going to look at gouge checking. And what we want to do is we want to make sure that the tool, as it goes down through here, does not run through the part. So we're going to do applied gouge checking to the cutting flute. You can see how it highlights here. We're going to pick all of those, but then we have to tell it what specific surfaces we want to gouge check for. So we're going to click this little guy right here, and this is going to allow us to create a new feature. And we're just going to select all the faces because we don't want it to actually hit any of those faces. We just want it to machine up to them. So we'll hit OK. We'll click that as our option. And now it will go through and run through an algorithm where it's going to try to make sure that none of this stuff runs into that part. From here, we're going to go ahead and hit OK. And then we're going to select Generate Toolpath. And you can see very quickly it came through and generated a toolpath. You'll also notice this dialog box comes up. When you run into multi-axis machining, you're going to end up with a process manager. And what process manager does is it actually allows multi-core process support. So if we had 10 different tool paths here we're trying to solve at once, it'll parse those up on different cores of your computer to run. But very quickly you can see that this is a pretty simple toolpath here. But what we're going to do is we're just going to take a quick look at traditional simulation of the toolpath. So you can see how it comes in. And we can slow that down maybe just a little bit. And you can see how it's actually going to run into the part. And then come out. We're going to turn the stock off just so we can see how the actual toolpath is going to run. And you can see that gives us a pretty good idea of how the tool is going to work. Very quickly, very easily, we have a toolpath here. You can see that down here in the bottom it does some extensions. You can also notice that right here it doesn't quite finish all the way out the bottom, and that's because the holder or the tool may not allow it to go that way without hitting the side of the wall.